We're going to be discussing how to find the rule for the nth term of an arithmetic sequence, but when we're given only information about two terms in the sequence that are not the first term, that don't include the first term at all, okay? Recall that to write the rule for the nth term of an arithmetic sequence in the first place, we say that the nth term will always be equal to the first term plus n minus 1 times the common difference, where the common difference is what it is increasing or decreasing by from term to term. Okay, so the key things to mention here are the two things we need to write the rule happen to be the first term and the common difference. And so when we're not given these, the question is, what is it that we can do about it? Okay, so let's look at this situation here. It says two terms of an arithmetic sequence are a6, or a sixth term is equal to 10. That's kind of the equivalent of saying, you know, the term and then the term value. We're going to say this. We have that the sixth term gives us a term value of 10, and then this one over here says that your 21st term in this sequence happens to be have a value of 55. Okay, so what we're actually going to do here is we're actually going to go plug these values into this rule over here. The thing to keep in mind though is this first value right here, this 6 and this 21, those represent the number of the term in the sequence here. So we're going to be plugging that in or substituting that for n, and then this second value here in each of these ordered pairs, or these numbers right here, 10 and 55, actually represent the value of that term at that given term number. So we'll plug those in or substitute those for that value right here. So let's go ahead and do that. We can go ahead and take this rule and we're going to substitute in for what we do know and not for what we don't know. But you'll notice here for this first one at least, I'm going to go ahead and write it like this. I'm going to say that I know that my sixth term is 10. So that is, the value of my term would be 10 if the term is the sixth term. And we can actually clean this up. We could say, well, then it is true that 10 is equal to a1 plus 6 minus 1d. We might as well just say this plus 5d. And I'm going to put a box around this because this is one of our equations that we need. Let's go ahead and come up with our other equation. And what I mean by that is we're going to now go plug this into this equation right here that we know holds true for arithmetic sequences. And what we would get in this instance is this right here. We would say, well, I'll try to partition this here. We say the value of my term is equal to the first term plus n minus 1 times d, where in this case we say our 21st term, so pardon me for writing very small here, we say the 21st term had a value of 55. So cleaning this up as well, we would say then 55 would be the value of my term, and that's equal to our first term plus 21 minus 1 is 20, so we get 20d, and I'll put a box around this because this is our second equation. So our method for solving for a1 and d here is to say that, well, we have two equations with two unknowns. What we could do is just use either substitution or elimination method, and we could just solve a system. So I'm going to go ahead and stack my equations here. We have 10 equals our first unknown plus 5 times our second unknown, and we have 55 is equal to our first unknown here plus 20 times our second unknown. And I suppose we could do substitution or elimination here, but I think that it's most convenient to do elimination because these, if you notice here, already have a coefficient of 1. So we could actually just go ahead, or they have the same coefficient. We can go ahead and take maybe this first equation times a negative 1, and we'll rewrite our system here. Our new system would look like this. We would say now it's negative 10 equals negative a1 minus 5d, and we still have the second equation we didn't do anything to. So we say positive a1 plus 20d. And then elimination method or linear combination say we'll just go ahead and sum these two equations. So what we end up with is this. We say negative 10 plus 55 is 45, and then a negative 5 plus negative 5d plus 20d is going to give us 15d. And so now we can just go solve for the value of d, and once we have the value of d, which by the way happens to be a common difference of 3 in this instance, we can actually go plug this back into one of our original equations here, and we can actually take our pick, either this one or this one, and I'm actually going to opt to plug it into this first equation here just because it has the smaller values in it. Okay, so if d is equal to 3, we say, well, we knew this. We said 10 is equal to a1 plus 5 times d, where in this case we're saying that we can substitute in the value of 3 for d, since we know that that's the value. So in this case we get 10 equals a1 plus 15, and if we subtract 15 from both sides of this equation, we can go ahead and isolate our a1. This would basically imply that 10 minus 5 is negative 5. 10 minus 15 is negative 5, pardon me. But it implies that our first term must have been negative 5. So just to go to show here, I put a box around both of these. We have our d value, we have our a1 value. Recall that what we wanted to do was find a rule for the nth term of the sequence, and we couldn't do this at first because we didn't know a1 and we didn't know d, but now we actually do know a1 and d. We know our first term comes out to be negative 5, and our common difference is 3. So that being said, let's go ahead and write our rule now. I say our rule would be an equals our first term, which is negative 5, plus n minus 1, that's a minus 1, times d, and our d is 3. Okay, so this is our rule right here. As a matter of fact, I'm going to go ahead and distribute this 3 through, and what we end up with is this. We say an is equal to negative 5 plus 3n minus 3. And if we were to combine like terms, at least combine the negative 3 and the negative 5, we get this. We say an is equal to this. We'd say 3n, and a negative 3 and negative 5 gives us a negative 8. So this right here, ladies and gentlemen, this is our rule, okay? And we can actually, verify this. We say, well, our first term is negative 5. Let's go ahead and prove this. If the first term in the sequence is negative 5, and it's going up by 3 every time, so go up by 3 be negative 2, go up by 3 again, it'd be a 1, go up by 3 again, it'd be a 4, and this continues on indefinitely. Maybe I want to say, does this rule work? Well, if I go to find a1, what this means is into our rule we can plug in 1 for our input value, that would be a 1 here, and we can see that we get 3 minus 8, and 3 minus 8 actually gives us a negative 5, so what this means is yes, indeed, a1 is actually equal to negative 5. So this will be our method that we use to find the rule for the nth term of a sequence if we only know 2 terms of the sequence and neither of them includes the first term, okay? So now what we're going to do is we're actually going to follow up on this by saying, let's use this rule to determine for which value of n we get an equal to 40. So the interesting thing here is this. Usually you get an n value, and you can go plug it into the rule and find an an value, but sometimes you get an an value, and we can actually go plug that in right here and go solve for the n value, which is what I want to know. So basically, what we're asking here is this. What term in the sequence would have a value of 40 if this is possible? So again, our rule is an is equal to our first term value plus n minus 1 times d, and that came out to be 3n minus 8 when we simplified it. But what we're going to do is we're going to substitute in for our an value since we have been told this. We've been told that the value of our term comes out to be 40. The question is, what term is this then? And we're just going to go solve for n here. So I'm just going to go ahead and add 8 to both sides here, and so we get 48 would have to be equal to 3 times n, and dividing both sides by 3, we actually determine this. We say then n equals 16. So basically what we're saying here is this. It must be the case that a16 was what came out to be 40, or this value of 40 has to be the 16th term in this sequence. And that'd be easy to actually go out and write out 16 terms of this, but you know what, it's a lot easier to just do the algebra. Cheers.